Okay, so this is section 2.9, proving lines parallel, and geometry, page 186. And we just talked about the theorems that we learned the other day, the postulates and theorems we learned in the other day, and they said corresponding angles formed by two parallel lines and transversal are congruent. That's a postulate. Then we learned the alternate tier angles theorem, which said if alternate tier angles formed by two parallel lines and transversal are congruent. And then we learned the alternate external angles theorem, which said alternate external angles formed by two parallel lines and transversal are congruent. And then we learned the same side interior angles theorem, which said same side interior angles formed by two parallel lines and transversal are supplementary. So then we talked about a converse, which we haven't had in a chapter or so. And the converse says if the original is if P then Q, then the converse is if Q then P. We switch the hypothesis and the conclusion, right? Well, that's what we're going to do today. We're going to have the converse. And the first one is the converse of the corresponding angles postulate. So we're going to switch the conclusion with the hypothesis. So we're going to start out by saying if the corresponding angles formed by two parallel lines and a transversal are congruent, then, oops, I'm sorry guys, I screwed up. It shouldn't say two parallel lines because that's what we're trying to prove. It should say if the corresponding angles formed by two lines and a transversal are congruent, then the two lines are what?
Parallel.
They're parallel. And this is not the corresponding angles postulate. I do not know how I can stress that to you. It is not the corresponding angles postulate. It is the converse of the corresponding angles postulate. All right? And this is how it says. It says if you have two lines, okay, and you have a transversal, and you know that this angle is congruent to this angle, all right? If you know in the beginning that this angle is congruent to this angle, then this line, we'll call it L, and this one M, and this T. Then if you know that this angle, we'll call this 1 and this 2. If angle 1 is congruent to angle 2, then L is parallel to M by the converse of the corresponding angles postulate. Do you understand that these are two different postulates? Do you get that? All right. Well, we have a converse of all of these.
What is it? An L what?
Then L is parallel to M. We have the converse of all of these. Okay. And so I'll let me see if I can write this out in a short way. Okay. If two lines and if two lines are, I should say are, am I writing big enough? Are intersected by a transversal. And bing bing. Number one, an alternate interior angles are congruent. Then lines are parallel. So if two lines are intersected by a transversal and alternate interior angles are congruent, the lines are parallel. This is called the converse of the alternate interior angles theorem. Does everybody understand that? Okay.
What does that say on the side?
Converse of the alternate interior angles theorem. That's the name of this. Now let's go back to the top and use the same. If two lines are intersected by transversal and alternate exterior angles are congruent, then lines are parallel. This is called the converse of what? This is called the converse of the exterior angles theorem. Okay? Now let's go back up to the beginning again. If two lines are intersected by a transversal and same side interior angles are not congruent but supplementary, then lines are parallel. And this is called the converse of the same side interior angles theorem. Okay, do you get that? What's wrong?
It says, next to number 1,
Uh-huh.
what is it compare?
No, it's this one.
Yeah.
Converse of the alternate interior angles theorem. These are all converses. Okay, I'm going to pause a minute. I need to pause, don't I? Are you guys behind a little bit?
Yes.
Okay, so I will go over these again while we're waiting. Remember that we had these from the other day. They were the original. Okay. And then today we're talking about what happens if we reverse it and we use a converse. And these are all true. And we have the converse of the corresponding angles postulate, which says if the corresponding angles formed by two lines in a transversal are congruent, then the two lines are parallel. Okay? And I showed you that one. Now the other ones also have converses. If two lines are intersected by a transversal and alternate interior angles are congruent, then the lines are parallel. This is called the converse of the alternate interior angles theorem. If two lines are intersected by a transversal and alternate exterior angles are congruent, then the lines are parallel. This is the converse of the exterior angles theorem. And finally, if two angles are intersected by a transversal and same side interior angles are supplementary, then the lines are parallel. This is the converse of the same side interior angles theorem. Okay, so these are all the converses of these. All right, do you get that? All right, and so there are two different theorems. So you cannot use one for the other one. And I always have students say, "Well, how do you know?" Well, if you start with angles congruent and end with lines parallel, then these are the converse. If you start with lines parallel and end with angles congruent, that's the original. So I can write that down. We start with first angles congruent, then lines parallel. That's the originals. Down here we have lines. Nope. Yeah, lines. No, I'm sorry. I screwed that up, didn't I? Whoops. Well, that didn't help. Did I spell that right? Yeah. This one starts with lines parallel. Thank you. Lines parallel, then angles congruent. This one goes angles congruent, lines parallel. Okay? For these ones. All right? Okay, I'm going to erase. You ready?
1 sec.
Okay. Got it? Okay, here we go. I do want to add two more in, and these are, they need to be in this section, but they are not of this. They're a little bit different. The first one is the parallel postulate. It's a postulate. It's not proven, but we can't find a counterexample. And it says if a given line and a point not on line, if given a line and a point not on a line, there's exactly one line through the point that is parallel to the given line. Okay? So the parallel postulate says if given a line and a point not on the line, so I'm gonna give you an example. Here's a line and here's a point. Everybody see that?
Yeah.
So this is a point and there's a line. We'll call a line L. There is exactly one parallel line drawn through that point. Now I said it a little bit differently. Okay, but you see that point?
Mhm.
There's only one line that you can draw through that point that is parallel to this. Remember, that's the symbol we use for parallel. Okay? And I don't care if that point is 6 inches above it or 2 inches below it. There's only one line that's parallel that can be drawn through it. Okay? And now we have the converse. And this actually, we learned this the other day, but the converse of the perpendicular transversal theorem. That means perpendicular. Remember, this means perpendicular? All right, and it says, in a plane, not in space, in a plane, if two lines are perpendicular to the same line, then they are parallel. Let me show you how this works. Okay, so let's say that we have a transversal, we'll call it T, okay? And it is perpendicular to this line. See? We'll call this A, right? And then we draw another line, we'll call it B. And it is also perpendicular to that transversal. Tell me about A and B.
Parallel.
They're parallel. They have to be. Okay, they have to. All right. Okay, so let's go to the exercises on page 190. Page 190. I'm going to erase. You ready? Okay. I'm going to attempt to draw this very quickly. We'll see how that works. This is R, this is S, this is U and V. And then we have, I believe, T, ooh. T, it's supposed to go right through there. Got a little shaky on that, but I was trying to hurry. Okay? Does that look about right?
Yeah.
Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Alright, we're gonna do 8 through 22, so we'll just start with 8. Alright, the directions say, given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. So, most people don't have trouble with the lines being parallel, they have trouble with the postulate or theorem, right? Well, let's take a look at 1 and 2. That's 8. 1 and 2. What kind of angles are they? They're corresponding. If those two are congruent, what lines are parallel? R is parallel to S. Okay, we have transversal U, and that would be what? The converse of corresponding angles postulate. Now, if on the test you put the corresponding angles postulate, I will check it wrong. And this blows students away because they think they're the same. They're not the same. If you end up proving two lines are parallel, then it's converse. Okay? All right. Should we skip around, or do you know this pretty well?
We should skip around.
Okay, let's go to you choose one. 3 and 7. This will be number 14. And it says angle 3 and 7. Angle 3 and 7. Can you say anything about 3 and 7?
They're alternate exterior.
They are not alternate exterior. No. 7 and 5 are. 3 and 7 don't help you, right?
No.
So you put no lines can be proven parallel. Okay? Questions about that? Any questions? How about 16 through 21? It says, find x so that m is parallel to n. Identify the postulate theorem used. Should we take a look at 21?
Yeah.
All right. See if I can draw this real quick. M and n. Looks like this one goes like this. Did they identify it? Nope. And this, right?
Yeah.
And they have, I believe this angle right here is 6x minus 134 degrees, right? And this is 2x. Okie dokie. Alright. So, let's say, well, 2x, what kind of angles are those? They're alternate exterior. And what do you know about alternate exterior? So I can say 6x minus 144 equals 2x. Is that correct? And we can do plus and negative. And can you work this out? You subtract. You got to subtract 6x from both sides, don't you? Get the x's on the other side. So I'm doing a negative 4x and then divide by negative 4. What do you get for x? 36? Okay, now, actually, you don't have to put 36 degrees. Why? I'm just out of curiosity. All right, because it's a degree sign up there and you're finding x. Right? Now, what postulate says this? All right, alternate exterior angles theorem. What if you put converse of alternate exterior angles theorem? It would be wrong. Do you understand that? Dylan? Okay, we're going to look at 22. Says, wooden picture frames are often constructed using a miter box or a miter saw. These tools allow you to cut an angle at a given size. If each of the 4 pieces of the frame material is cut at 45 degrees, will the sides of the frame be parallel? Explain your reasoning. Okay? So a miter saw, you take a piece of wood, okay, and it cuts it at 45 degrees. Here's your piece of wood. It cuts it at 45 degrees. Have you ever used one? Okay, no? Okay, so if you cut it at 45 degrees and you take another piece and you cut it at 45 degrees, what happens? They make a right angle, right? Okay, so it says, will the sides of the frame be parallel? Yeah. Because this is a right angle, isn't it? Okay? So, yes, they will be. Why? They form a 90-degree angle, right? They form a 90-degree angle. What else? So, in other words, they're perpendicular if they form a 90-degree angle, right? So by the, what did we learn? By the, what does this say right here? I erased it. By the converse of the perpendicular transversal theorem. You remember what it said?
It says, and in plane, the two lines are perpendicular to the same line, and they are parallel.
That's right, they're perpendicular to the same line, then these two sides are parallel, right? Okay. If you look like that, those two sides are parallel, aren't they? So by the converse, perpendicular transversal theorem, the two sides are parallel. All right? Do you have questions? Okay, we're going to do page 190, numbers 2 through 22 even. Nope, not even, all, sorry. Got a little crazy there. Would you write that on the board, Chin? Okay. All right, any questions?
I thought it was 8.
It's 8. It's a, man, let's get that right, Mr. Ells. It's 8 through 22 all. How's that? Chin?
It's alright.
Oh, it's already up there. Well, no wonder. I couldn't get it right. All right, any questions?
No.
All right, good luck.